Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. In how many ways can 4 different books be distributed among 4 students such that the number of students who do not receive a book is no more than 1? So this is not exactly the run-of-the-mill permutation problem. So we are given 4 different students, right? And we are given 4 different books. And we have to distribute the books among the students. Now, one thing here to keep in mind is distribution doesn't necessarily mean an equal distribution. It doesn't necessarily mean that the books have to be distributed among the students so that each student gets 1 book, right? So the way a distribution may be described generically is, each student may get 1 book or may get no book or may get more than 1 books. So the number of books, of course, will still be, adding up to 4, right? But we have to keep in mind that this is not necessarily the distribution where each student gets, one book, which is kind of, distributing the books equally. So with that in mind, the problem states the number of students who do not receive a book. So there may be, students who do not receive any book. And that number shouldn't be more than 1. So that's something you have to keep in mind. And what it means is the number of students who do not receive a book is either 0 or 1. So those are the only 2 permissible values. So let's consider the students be PQRS and the books be ABCD. So that, we just have, a name for every student and a name for every book. So we realize that all of these, quantities are different, which is important when we are considering a problem in permutation. So from here on, we consider the simplest case. And the simplest case is when the books are distributed equally, meaning each student gets 1 book. And in this case, it's worth noting that the number of students who do not receive a book is basically 0 because each of the students are getting 1 book, right? And how many permutations will be there in this case? Well, it's very simple. It's just factorial 4 equal to 24 ways. And in many of the simplest permutation problems, that's where, you get your answer. So your problem is solved right here. But not in this problem, because in this problem, we have to also consider the case where there may be 1 student out of those 4 who does not receive any book in the distribution. So what is this scenario going to look like? So let's consider that. So that's why we have, these notations PQRS for the students. And let's assume that in one such scenario, P is the student who does not get any book. So P gets 0 books. And then we have the remaining students QRS. And so we have 3 students and, we are distributing 4 books among them. So 1 student will end up with 2 books, right? And let us suppose the distribution of the books in this case is going to be like that. So Q gets A, R gets B, and S gets 2 books, C and D. And the order of those 2 books doesn't matter here. So S getting C and D or D and C is basically the same thing, right? But when you consider amongst Q, R, and S, they can be basically, permuting amongst themselves in factorial 3 ways, which essentially means that instead of S getting the 2 books CD, R may be also getting the book CD, and S may be getting B, or S may be getting A, or Q may be getting CD. So Q, R, and S being different, different individuals, so we have to consider the fact that the distribution will be different if, Q, R, and S basically changes the order in which they receive the books. Meaning, there could be an order like Q receiving 2 books C and D, R receiving the book A, and S receiving the book B, and so on, right? So that's why we are doing this permutation. And this permutation among Q, R, and S. So we have just three entities, and we are permuting amongst themselves. So that's why it's factorial 3. Next, we have to consider the fact that CD could be basically any 2 books among the books A, B, C, D. So we have just considered one case, to better understand the problem, right? Let's put C and D together as the 2 books that one student may receive. But those 2 books could be any 2 out of A, B, C, D. So essentially here we have 4C2, which comes to factorial 4 divided by factorial 2 multiplied by factorial 2 in the denominator, and when you evaluate this comes to 6. So we have basically 6 different ways of choosing these 2 books, which goes to one particular student out of 4 books. So that being taken into account, now we have to focus our attention to the person P who receives no book. Well, in this example, we have chosen the person as P, but P could be basically, this person who receives no book, he or she could be basically any one out of those 4 students. So essentially, we could, choose that person in 4C1, which is equal to 4 ways. So the total number of cases in which one student out of 4 gets no book would be basically you multiply all of these together, and then you get 144, right? And then if you add up these 2 numbers that I have in the purple box, you get the total number of possible distributions, which satisfies that the number of students not receiving a book is no more than 1, and that will be equal to 24 plus 144, which comes to 168.